Okay, thank you everybody for coming to this talk. We're gonna discuss a very interesting topic this morning, not this afternoon. It's a combination of two very important initiatives for Schneider. One is around partnerships, and the other one is around DC microgrids, which is a very interesting new technology that we see emerging. When we think about the importance of partnerships, this is actually an interesting way that we'll talk about. We have with us John and Sebastian. So you guys just want to do a quick introduction?
My name is John Moy, one of the partners from Schneider Electric in the Netherlands, already for quite a while, and we're doing everything with panel building, from panels for industry, tertiary, but also for machine builders, and data centers, of course.
Okay.
Hi, my name is Sebastian Greiner. I'm the managing director for DC Systems now for the last 3.5 years, and I mean we are trying to DCify the world, so that's what we're going to speak about.
Okay, so if I just go introduce pretty quickly, we talked about this. When we think about sustainability, but really if I take a step back, DC microgrids is a very exciting new space. We like to think of it as it's filling in a niche in the market that is very much needed. We'll tell you why that is the case. But we'll also talk about how we leverage our partnerships to be able to really drive this space and be successful in a very transparent fashion. So if we go to the first one, I mean, I'll turn it over to you, John. Can you tell us a little bit more about Elektro Internationaal, what you do, and how this came about?
Well, we are, what I said, just a panel builder based in the center of the Netherlands already for nearly 40 years. We build panels for all kinds of markets, especially for the data center market. And we do it with, not all brands, but we do it just with one brand. And that's the brand Schneider Electric. And that's not a secret reason why we do this. We would like to be a specialist instead of a generalist. And we dived into the deep with Schneider already for 30 years ago.
Oh wow, that's quite long.
That's quite a long time, yeah. We do it with roughly 100 people. And sometimes we are asked by Schneider to do and to make special projects for them, and also special products for them. So,
focusing on which application usually?
Focusing on buildings and for data centers. That's the main business we are into. Yeah.
Okay. So now you look at the chart behind us. Tell us a little bit about the situation with the grid in the Netherlands specifically, how it impacts your business as a business owner, as well as other industries and buildings around you, and what ramifications does that have?
Yeah. Well, Sebastian, do you tell this? Because we are both, of course, involved and...
Yeah. So I mean, for me, that picture basically always shows perfectly how much we are taking energy for granted.
Yeah.
So, I mean, it's 5:12, right? So this is the situation in the Netherlands. So we are seeing here actually everything what is red is like the grid congestion. So it's basically there's no capacity left in the grid. And I think when also speaking with John, that's exactly what a lot of company owners are basically facing now in the Netherlands, right? So you want to build or extend your factory, you're asking the utility supplier for an extension of your grid capacity, and then comes like, you're asking for 640 kVA, for example, to build your factory.
630, yeah.
And they tell you, you can have 400 kVA for the first 2 years or something.
Or even less, yeah.
And then it's basically, okay, what should I start first? Is it the coffee machine? Is it the conveyor belt? So you have to decide and make some decisions as a business owner. And I mean, you can tell better what that would mean for you, especially with all the other things we are facing also now.
And this situation is getting worse and worse in the Netherlands because the government and let's say the whole environment forces us to go more sustainable. So we need to go on electricity with our cars. We need to cook on electricity instead of natural gas, but it all pumps up the electricity market. And as you can see on the figure shown, everything, all the places are in red, and in red means that there's no electricity available at the moment, and it's getting worse and worse every day. So we need to find new solution to solve the problem. We are a small country in the center of the Europe, and I assume that this will come more to other countries in Europe as well. Huh? Don't you think so?
That for sure. So again, we are taking energy for granted because we are not seeing that kind of problems, but we don't have anymore the capacity in the grid. So we need to really rethink the way we are working with energy, and how we can, be more efficient and also like really battle that kind of things. Because like you said, we are seeing now, especially in the Netherlands, we are seeing a higher rate of adoption of electrical vehicles. We are now, everybody wants to go through heat pumps, we want to get rid of the gas, that's also one of the big challenges for us now, while getting also more, CO2 reductions, being more sustainable and all these kind of things. So that's basically exactly what we are also doing then with DC systems, right? So we are trying to rethink a little bit the way we are distributing energy. So it's a company based also in the Netherlands, and we are really trying to take a normal AC installation and also implement a kind of DC microgrid inside your installation. So we call it hybrid grids. And that's basically one of our solutions, because exactly we see always when we are going for our projects, what we could show was always usually 4 benefits. So one is the grid capacity reduction, because we're working with prosumers, with batteries and all that kind of things, so that we can, we are working actually behind the meter, so we can take a lot of the stress off the grid. So another topic we always see in our projects as well is good efficiency increase. So we are 7 to 10% more energy efficient by just changing the way of conversion. So we are sometimes, every device usually needs an AC-DC converter. Even we are reducing this completely, or we are going to a more efficient DC-DC conversion. So
before you even go there though, John, you're a business owner. What is the impact in terms of your own facility, permitting? What does it mean for business owners? We all heard about this big data center boom that is happening really all over the world with AI, the amount of energy intensity that is required to run these. How is all that going to factor into what you have today and what you will see tomorrow?
Well, what we had in the past was a good market in the market where everyone could build his own factory or doing his own business. But nowadays, you are willing to start your business, but you're forced or you're stopped by the government or the electricity authority because there's no electricity. So your total business stops. So you need to find a new solution to get it rolling again. So we don't have business. You don't have a permit and you don't have access to the grid because they forbid you to get the connection. So if we ask, for instance, we need, and for our site, that's a very accurate purpose. We are planning to build a new factory. What Sebastian already said is we asked for a certain grid connection and they don't allow us, so we need to find other solutions in order to get enough electricity for doing our business, what we want. And that's almost for everything. That's for a data center, that's for a normal utility, but even for houses, they don't get the electricity to build a house.
And I mean, it started like 4 or 5 years ago that data centers in these areas which we're seeing here red, they were forbidden to be built. So that's then the last way out of a government to say, okay, we want to go with residential maybe, that's still what's allowed, but the data centers is then forbidden. So, and stuff like that, then our business owners really affected. We were also seeing, so as we speak, I think in February was an article release, so what we're also writing there is like, 9,400 companies were waiting or filing for an extension.
Just imagine, 9,000, and it's getting more and more every day.
Yeah, exactly. And that is crucial for some of the business plans. Imagine you have a good business idea, you want to open a logistic park or something, and then it's like, okay, the business plan is standing, you get your approval, you get the money, everything, and then it's like, yeah, by the way, just your utility supplier is telling you, okay, you can't build and open. So that's why we are looking desperately for that kind of new solutions.
Yeah.
By the way, we're seeing the same type of situations, not frankly as dire in the UK, because you see a lot of the countries that have pledged on EV. Yeah. As you start putting in more and more EV charging stations, they need power, and a lot of the grids locally are not able to handle that. So they're starting to see the same situation. And we see the DNOs starting to say, depending on what the country is, that we're going to have a problem. So that creates, the logical solution is a microgrid, right?
Yeah, it is.
Now, let's talk a little bit, Seb, about your business, DC systems. And tell us a little bit what is different, because we have AC microgrids, and there's a lot of people that are able to go do those.
Everyone
What's
speaks
different,
about it,
and how does this, tell us a little bit more about your business.
Yeah, so like I mentioned, so what we are basically just doing with the company is we are trying to rethink a little bit the way we are distributing energy, right? So we are all very familiar, especially also Schneider is very familiar, with the way of AC installations and everything. And it also is like, working for like over 100 years. So mankind built this kind of distribution system. What we are trying to do is like to try a little bit being smarter and more efficient. So we are not saying AC or DC. We are saying let's take on the DC side what makes sense naturally. What is DC? So photovoltaic, electrical vehicles, battery solutions, all those kind of loads are naturally like already DC technology. And at the moment we are using always a kind of small AC/DC converter in front of it to convert it to make it work. And what we are saying is like let's skip this. And let's connect directly on DC. And what I was mentioning before, in the projects we have been realizing so far, we could see just by doing that, we could be 7 to 10% more energy efficient. There's even other applications which can benefit way better from that. So think of a robot.
Far above 10% better.
Yeah, yes. Because think of a robot, for example, right? So nowadays what happens is like the robot is accelerating and braking. And while doing that, all the energy is pushed into a braking resistor. This needs to be cooled and so on and so on. If we connect the robot directly on a DC bus where battery is coupled or other loads are already also coupled, you can do a load sharing. And this can bring you, 15 to 25%. Some studies from Germany were showing that it could show you like 15 to 25% of energy efficiency. And I mean, for me as a factory owner, that would be nice if I can save a quarter of my energy bill, basically. Right? Yeah. So that's one thing. The second thing we are seeing is that we are also more resilient, basically, because in DC you can also do different ways of distributing the lines. So, for example, we could show that we can distribute one load through two lines and connect it still. And when you are shortening one of those lines, for example, still the other one takes over, which is pretty nice for data centers. So uptime is a big topic there. So that's one benefit which comes also with DC directly. We see, for example, some benefits on islanding mode. Since we are like a grid inside the installation, we can run this kind of installation then, autonomously. So we had once a kind of case that a building in Amsterdam, in the south area of Amsterdam, where actually everything is new built, was running while everything else was facing an outage. So just running on battery and PV installation. So that are like, the big benefits we are seeing. What we are also trying then to do with DC systems, and we are then trying, to exactly execute those kind of projects. So customers come to us, we are consulting them, we are helping them, figuring out and specifying, and then realizing that is also with our products. Yeah. And usually what we also can show, that depends on application by application, is like, that we are also saving copper, because we are stepping up a little bit voltage, so we are reducing, the cross sections, and also going a little bit then more like on copper saving, which is also generating CO2 savings. But that depends really sharp on the applications itself. So yeah, that's basically what we are doing, and I think so far we are doing that pretty well. And for example, one of those projects we are now at the moment investigating together is that we are looking into a kind of EV in a box, we are calling it, and we are also showing it actually the first time here as on the booth on the Innovation Summit. So you can come afterwards and also check that out, because I think that's very interesting. So we are working with a normal connection. Basically, we are just connecting the AC grid to that container, and from there on we connect PV panels and everything. So,
And what with that solution, we solve a problem because the grid connection isn't large enough for us. And with the containerized solution, we can increase or decrease the grid connection with 30 or 40% to combine the normal grid with the DC grid. So there's a smart, and I think that the solution needs more explanation. What you have.
Yeah. So, like I said, we are really coming. Basically, it's scalable because we are putting everything what is like more and more on the. Actually, what you would connect on the AC installation and would require power from the grid and also from the utilities, we are trying to put in this kind of DC grid. So, and from there, we can limit, and we don't need to show that to the utility supplier. Because on the DC side, we are working with prosumers, we are working with battery buffer, we are working with a lot of different things to make it possible that an energy management system by itself, so we call it droop control or current OS. So let's say a kind of special specification, which is like telling the loads exactly when to act. And through that we were able to reduce for your building in this case, because nowadays you were also asked to connect more and more EV chargers by the European regulations.
We are forced to, yeah.
So every fifth parking lot has to have every new build company has to have every fifth parking lot needs to be an EV charger. So, and with that we were securing that you are able to provide the chargers while still having the company running on that kind of limited grid connection we were seeing. So I think that was a pretty interesting thing. And actually the story how we came there was more funny because we were just actually looking, because we're also seeing obviously a lot of challenges, right? So we are now looking for components which we were not used to. Last year was a big supply chain crisis. And we were also trying to scale. So, because most of our things are like handcrafted for the time being. And we were looking for a partner helping us building this kind of 700 kilogram panel. And that's where we were looking then to John, because I was aware that Elektro Internationaal is one of the panel builders in the Netherlands. And so we reached out basically to you, and then afterwards we were just in the discussions and saw that you were also increasing the building. And that's how we came actually together with that.
So we build them in serial types, numbers. Yeah.
Now, are you going to leverage one of these panels in your facility itself, and are you going to have a microgrid in a box?
Yeah,
for your
for
facility
sure.
yourself?
For sure. Yeah, we need to, because otherwise we have no capacity from the grid to feed all the electro vehicles. So what we do is we are going to use the solar panels to feed directly the EV box. And use all electrical power to flatten, let's say, the consumption of our own building, and that decreases the total consumption of the top consumption of the building. So instead of 630 kVA, we were handy enough with that system to go down to 400 kVA, and even I expect that we go for even further down.
Do you have to go permit this with the utility company?
No.
How does it work?
No.
So because for the time being, that's also one of the challenges we are facing, right? So everybody is like then shying out usually due to missing regulation or standards for the time being. But that's also where we are working together with the customers. We are saying, okay, let's build that. Let's go to the local authorities. Let's have checked what is actually requirements, for PV installations, for battery solutions. So all that kind of things we are then also helping and going through and trying then obviously to place that then in the field. It's a little bit challenging because also, in Europe, country by country, it also differentiates a little bit. But that's what we are trying to do and where we try also to support. And I think there's really a kind of big demand, what we could see on the picture before, and many companies are actually looking for that kind of solutions.
Yeah, and many companies they speak about electricity in the box, but there's one thing different. What we do, we don't go out with AC. We use everything on DC, so that makes the difference.
Yeah, because we don't want to, we call it now EV in a box because we just started with the EV chargers around it. But basically from there we can connect everything, like your lighting in your factory, for example. You can also connect, if we are having OEMs we are working with together, then who are building refrigerators, you can connect those kind of things for the retail shops. So it actually can become DC in a box. But so far we were starting, because we see that need. Because now these regulations are popping up a lot, aren't also going to be enforced by the European energy building directives. So that's why we started with the electric vehicles for you. And I think we will see more and more to really bring the loads on the other side. But that is also where I'm looking a little bit back to you, how these big manufacturers are then, helping us to
I've seen some nice products on the booth. From DC powering electric vehicles. So, but do there come more?
So we've been down this journey, and one of the things that is, to me, quite interesting is when you go into a native DC type architecture, one of the biggest concerns, and I'll say, even from our own CEO, our ex-CEO, his question was, wow, 600 volt DC, that is a lot of energy.
Yeah.
So how are you going to be able, how do you make sure you can protect from that energy?
Yeah.
Right? And so when people think DC, they try to use the traditional breakers and everything else that we have. That becomes a limitation.
Yeah.
The good news is with the advancements in solid state technology, we start to see, it's still expensive, but with silicon carbide and some of the new technologies that we have, number one, you start to see the cost come down. So some of the technology stack that is completely different for this type of an application will be, you need more power electronics, right? So whether it's the AC-DC converter up front, it's the interruption or the circuit protection, which also needs to be solid state. But then you also have our busway and all the other, so that technology stack is completely different, number one. We have to make sure, and in some cases what we are learning, the Dutch authorities in some sense are working with us and are quite, I'll say, much more technically savvy in terms of what the applications are and how we are doing it the right way. A lot of the other countries, they are still just trying to learn, right? So from my perspective, to make this successful, number one, it has to be application-based. So certainly EV in a box is one application. We see this, by the way, proliferating very heavily in China, which is really adopting DC, and I think adopting DC in many ways that is faster than the rest of the world. There are associations, so we have ODCA, which is really a factory DC type application that's in Germany, and that's a consortium. We see Emerge Alliance in the US. We see CABI, which is a consortium of a lot of folks in China, really being driven with the southern grid, the south grid of China. But all of these, in the end, work with, from our perspective, we have our own foundation called CurrentOS. You might say, is this a Schneider foundation? Not really. What we are trying to do is really create the interoperability standards between all the different manufacturers. So whether it's the OEMs, whether it's the device manufacturers, the system integrators, in one way you can really deploy DC at scale for the applications that make sense. If you have the same language, if each device doesn't need a custom converter. So this CurrentOS foundation that we have, we've had it for a few years. The founding members are us, Eaton, ABB, and we also have UL, which is one of the standards bodies in the US. We are working actively with all of these associations that I talked about. And finally, we've increased the size of the number of members of CurrentOS. We've doubled. Hager recently joined. We have a lot of the manufacturers. We have Fuji Electric, some of the folks that are in the audience today. So really the goal is not to make this a Schneider-specific standard, but to make this something that is interoperable. So when you as a consumer or as an end user, decide to go take this technology stack, it's plug and play. Right? One of the things that I like the best about the way these DC microgrids work is they're extremely scalable.
Yes,
right? So if you wanted to add another EV charging box, tell us a little bit about the simplicity of that.
It's very simple, yeah. But it's simple due to the current OS foundation, which sets up certain behaviors in a DC system, and that's what you more can tell, Seb.
I mean, that are the two unique things you need in a DC microgrid. You need protection, so otherwise DC becomes dangerous current, and the solid state protection is like a way of super fast braking actually. So that's why it's manageable, and it's also one thing what DC Systems has in this offer portfolio. So that's exactly one thing what we're working with. And the scalability needs to come from exactly like a lot of manufacturers. It's not just Schneider, not the Eaton, not the ABB itself, all of them together, because otherwise we don't see enough applications. Because let's be honest, even Schneider or Siemens or whoever is not big enough to change overnight or in 5-10 years even what mankind was like, building over last century. So that's why we definitely need to have that kind of foundation, and I always compare it to a kind of USB standard in front of the socket. So that's basically how I see current OS, and that's why I'm also very happy always to see more and more people coming, joining. I'm always excited when I see a new product coming up, so I usually put it directly in our garage downstairs to the engineering team to connect and play around with it. Yeah. So, what is it? How can I break it?
Isn't only for big manufacturers, even for us as a user, there are Ruby contracts. Ruby is the lowest level from the current OS foundation from which you can use the knowledge. And we are also a Ruby member, yeah.
Okay, so to conclude the topic, and we only have a couple of minutes left, people generally ask us a few questions around the topic of DC. So the first question is DC safe? I think the answer is yes, if you do it responsibly and if you do it the right way.
More than
we absolutely agree.
Yeah, more than that.
And there are people who will swear by it, and we swear by it. Again, done the right way. Second question is it more sustainable or is it more carbon efficient than AC? The question, it depends on your application.
Yes.
And it depends on how you deploy that application. So we are learning specific applications, especially which are highly, the loads generally tend to be a DC a lot, but if the sources are a lot more DC, you start to see these becoming a lot more efficient. And the third one is it cost effective? And to me, the answer is, again, today, yes, depending on the application, but as we see the cost of semiconductors start to come down, and as we start to see the proliferation of these devices, if we have the standardization, so if each person doesn't try to build their own DC grid with their own language, with their own interoperability, I think absolutely it can scale. And for the right applications, these advances will far outweigh the simplicity, and the scalability will far outweigh AC in those applications, and we are convinced about it.
You have to learn about it, but as soon as you know the rules, it's much easier.
Okay. So tell us, where can people learn a little bit more about what we are doing, both online and also in terms of being able to see, witness, see and feel what we're working on?
First of all, so everybody in the audience can visit us on the booth, obviously, where we're showing also the EV in a box model. They can go to our homepage, dc.systems. Otherwise, it's also just give us a call, get my contact details. We will for sure have a big opening of the experience center.
And we just introduced our own site.
Exactly, and then also on Elektro Internationaal, they also just launched their own DC microgrid site.
In which all the solutions from DC are noted.
Exactly, so I think you're pretty good when already looking up to this, and then reaching out to John or myself when you have questions for that. So we are more than happy to help, to answer, and look through all the stuff.
And we're also looking to have some formal training videos that we will launch shortly, just learning videos that will be available online as well if people just want to learn. But we again welcome you. I think this is the end of our talk. Yep. But we welcome you to go back to take a tour with us to the floor where we have an example, and the guys can actually show you how this works in action and not just in theory. So thank you very much.
Thank you.
Thank you all.
Thank you, John. Thank you, Seb.